In this video, we're going to find the atomic mass from percent natural abundance and isotope mass values. These problems typically start out with a table of information like this. Here we have two gallium isotopes, gallium-69 and gallium-71. We're given the mass of those two isotopes in atomic mass units, and we're also given their relative abundance in percent. Notice that the 2% relative abundance values sum to 100%, so we know there are two isotopes in this particular population. One of the first things that we need to be able to do to answer these types of problems is convert the percent natural abundance to fractional abundance. So let's convert the 60 not to 60%, but 0.601. That's the fractional form. Notice that the 2% abundance values sum to 100, and the two fractional abundance values will sum to 1. So to calculate the average mass of a gallium isotope, we need to use the weighted average of these two mass values and those fractional abundance values. The general equation for that is the atomic mass, given the symbol A, is the mass of one isotope times its fractional abundance plus the mass of a second isotope times its fractional abundance plus the mass of a third isotope times its fractional abundance, and on for as many different isotopes as we have. In this particular problem, we only have the two isotopes, so we'll only use the first two terms of this equation. I'm going to rewrite it using the 69 and 71 subscript just to make it very clear where these numbers are coming from. So to calculate the average or the average molecular weight in atomic mass units, I'm simply going to plug in the mass for the element isotope 69 here and the fractional abundance of it, and then add to that the mass of the 71 isotope and its fractional abundance. If you evaluate this quantity, you can get the average mass of a gallium atom within this population, and you get a value of 69.72244, and that's AMUs per gallium atom. Next, I'm going to take this 69.722 AMUs per gallium atom and convert it to grams per mole. So a number that you're perhaps more familiar with looking at the periodic table. This number would be much more convenient if we could convert it to not AMUs per average gallium atom, but if we could convert it to a grams per mole quantity. That's a number that's more useful for future chemistry calculations. So let's go ahead and do that conversion quickly here. To cancel out the atomic mass units, we know that 1 AMU is 1.66054 times 10 to the negative 24 grams. So what I'm doing here is I'm canceling out the atomic mass units and converting that to grams. Next, we don't want this quantity in terms of average number of gallium atoms. We want it in a grams per mole. So we know that there are 6.022 times 10 to the 23rd gallium atoms in 1 mole of gallium. If we compute this quantity, we get the answer 69.72 grams per mole. So that's how many grams of gallium there are per mole of gallium, and this is the number that you'll find on the periodic table. Notice that it's actually the same numerical value here. We just went through the process of converting the units.